The ES331 mechanics material. And before we started, let me introduce myself. And my name is Cheng-fu Chen. I'm professor of mechanical engineering. And here the topics basically in our semester, basically we have two major topics. The first topic is about the analysis of we call the stress. Stress is the response of the material to loading. And the second portion, not showing here, the second portion is about how to analyze the stress in a way to fit into design criteria. And for the first portions, and about the response of the material to loading, and which we call the stress. Usually we have four different types of the loading. And chapter 2 will talk about the loading, which is the normal to the basically parallel to the axial direction. Here is what we call the axial loading, axial normal loading. The chapter 3, the loading type is torsion. Okay, just kind of twisting on a shaft. And chapter 4, we're going to talk about the bending. So basically the bending, the loading type is a bending about the beam. And the last one is the we call the transverse loading. Transverse loading, just like shear, we're going to kind of cut off the material, and that is the one. And pretty much once we've been through the four loading types, we pretty much been through the second portion, and that will be taken up to about the first half of the semesters. And chapter 1. Before we touch in all the topics, chapter 1 is about the introductions, about the stress. What is stress? And I will give the very detailed definition and exercise. And also chapter 1 will talk about a little bit the preparations about the kind of reliability things. And so chapter 1, we're going to talk about the stress. And basically stress has the same unit as pressure. Okay, so before we go back on this level of our this chapter 1, and by the way, the slides should be made available on Blackboard. So then the slides won't directly cover the whole textbook contents, but I will try to give the highlights and the guidance. So here is the topic going to go through the chapter 1. And the first one, I'm going to review the free body diagram. These techniques will be used from the day 1 to the very last day of your final exam. So if you still need certain refresh on the free body diagram, and probably you need to dig out from your statics books and get familiar with, but also through the exam, through the examples in the class, in the semester, I will use the example to demonstrate the techniques necessary. And then I will talk about the definition of the stress and type of the stress, unit of the stress, and direction of the stress. And those one will be served as a very fundamental concept and for the stress analysis. And then the last one, talk about the factor of the safety. And this factor of safety going to use in pretty much in every single chapter. So that concept is important. And before we introduce the type of the stress, and here I kind of give you in general, we can classify the loading into, first one is normal loading. Here, sorry, it's called the uniaxial loading. So that means this loading is basically one single pair and in one axis. We call it unit, okay, one direction. Axial, that apply to the axis directions. This one called the shear loading. Shear loading, basically, the feature is the direction of the force is parallel to the cross-sectional area, as opposed to the axial loading, which is normal to the normal direction, the cross section. So that one, if that is the best way to distinguish what is the shearing stress, what is the shearing force, or shear loading, as long as you identify cross-section of the interest, and then if in that cross-section you would find any force component that would be parallel, then that force will be classified as the shear. And in general, we might have the general axial loading, which means in terms of this case, apply in x direction, for example, and then we might superpose into y directions like this, and also superpose into z direction. So this one is called the general axial loading, and from the three directions, or the loading are normal to the individual cross section. And here I didn't draw it, but you could imagine this one could also have the general 3D shear loading situations. So those are the introductions about the type of the loading. So now we come to the very first topic, and what is stress? Basically, the stress is, by definition, is force per unit area. So, for example, we'll look at here. So, among these here, let me make one example. If we consider two sides of the area, so say if I apply, say, 100 pounds here, then apply the same 100 pounds here, then per our definition, for example, let me say this area is, say, for example, 10-inch square, and say this one, for example, this is 20-inch square. And say, for example, if I apply the loading here, say the loading pounds, say this is 10 pounds. So in this way, in our calculation, the stress for this case will be equal to loading divided by area 10 pounds divided by area 10-inch square. For this case, the stress will be equal to 10 pounds divided by 20 inch square. So this value will be the stress, and then this one will be equal to 1. The unit is pound per inch square. This one will be equal to 0.5, and the unit is pound per inch square. So these are the magnitude and the unit of the stress. So basically, we look back to here. The basic stress is the force per unit area. In calculation, we simply divide the magnitude of the loading to that cross-sectional area we considered. Okay, and so that is the basic definitions. And later, I will give you more introductions about the unit of the stress. So from here, before we go for the detail, basically you can see the stress is the force per unit area. So basically the stress has the same unit of the pressure, and again pressure is the force per unit area. So simply in concept, you might imagine the stress and pressure basically are the same quantities, but in physical application they have the different explanations. This one we talk about is about the stress concentrations. And usually we come to here is this. If you could imagine here, the loading is applied to here. And you can see here is a pin here. Once I pinned, I kind of deport this board, you could imagine locally, if I would pin around this area, pin here, then locally here, you would feel that kind of highly concentrated. And outside the application of the loading, then the outside area will be less stress, and that is our common sense. Or you can imagine using the needle to poke your skin. So likely you will feel, okay, locally that part, that spot is being poked is very painful. And that is caused by here, this is we call the stress concentration. For example, here for this drawing we're showing here, we apply the loading and to this surface. And if we take a cut and say expose a cross section just nearby where the loading applied, like here, okay? So we take the cut, this cut expose this cross section. This cross section is very close to where the loading applied. And then the drawing here showing is the magnitude. And the larger the arrow, meaning the larger the stress of the value of the stress. And so you can see this drawing is basically showing nearby the application of the loading, the stress has a much larger values compared to any stress that is farther away from where the loading applied. Okay, the same concept, if we take another cut here, that is farther away as compared to this cut, so you can see the distribution of the stress in a way that is smaller. Okay, if we take a further cut here, so basically the distribution of the stress is getting more uniform, like this one. Okay, so for this case, this phenomenon is we classify as we call it stress concentration. Stress concentration is a very non-uniform, highly complicated phenomenon. And in this class, ES 331, we won't talk about this topic. In ES 331, we just simply assume the magnitude of the stress is like this, uniform everywhere. So this is a very important assumption, and this assumption will make our calculation much, much easier. Okay, so we can take a break here.